We are on lesson 3-2, factoring with a ninja star. Our objective for today is to do what? Gunner was first.
Factor quadratics with a leading coefficient of 1 and a leading coefficient other than 1.
Yes, all right. By the way, today's date is Tuesday, September 29th, 2020. And I actually am looking at that objective. I don't think we learned how to do... Oh, yes, we do. Okay, never mind. That's correct. All right, so same 2 steps from yesterday. Jade.
Can I put this one down? Because nobody's sitting there and doing this.
Yeah, that's fine. You can just lay it on the desk. What are the factoring in 2 steps from 3-1 from yesterday, Andres?
Divide the... Wait, is it divide?
It's factor, I think, is the word you're looking for.
Yeah, factor.
Factor what?
The GCF.
There it is. And what about step 2?
Add exponents.
Not quite, but good guess. What?
Ninja star.
Ninja star.
Oh, yeah.
If you remember from yesterday, I said all we're doing in 3-1, yesterday's notes, was doing factoring out the GCF. Now you are experts at doing that, so we're going to do the next step, how to do the ninja star. You will not be experts by the end of this lesson unless you've remembered everything from Algebra 1, because there's a lot to the ninja star. We haven't even touched on advanced ninja star yet. That's not today. All right, so again, distributing versus factoring. If I go ahead and distribute these, I can either FOIL this out, first, outer, inner, last. The acronym is FOIL. Or I can use a general rectangle. I'm going to go ahead and make a really quick general rectangle. I'm going to do 2x plus 3 and x minus 5. Someone help me fill in this general rectangle. All right, Charles, then Gunner.
2x squared is the top left.
2x squared. Gunner.
Top right is 3x.
There it is. Bottom left. Jade.
Negative 10x.
Negative 10x. Bottom right. Wyatt.
Negative 15.
Negative 15. I add these all together and I combine like terms to get what? Combine like terms. Jade again.
2x squared minus 7x minus 15.
Minus 15. Yeah, the 2 like terms were the positive 3x and the negative 10x. All right, so that is a review. Can you guys give me a fist of 5? How well do you remember going forwards? How well do you remember doing this, multiplying? 5s, 4s, 4s. Is there any 1 out of 3 or under? No, okay, we're doing good. All right, we're going to do the reverse of this. All right, so we're going to be using the ninja star, the normal ninja star, not the advanced ninja star. The normal ninja star is only when these 2 conditions are met. First, it's a second degree trinomial. Trinomial, that word starts with T-R-I. What does trinomial mean? Trinomial. Charles.
Like a 3-part term. 3 terms.
3 terms, there it is. Notice over here, I have x squared plus bx plus c. There are 3 of those things. Again, terms are separated by a plus or a minus. What does second degree mean? I can use a different color here. Second degree.
Not third degree, but not first degree.
I need a quiet raised hand next time, Gunner, and that is also incorrect. Jose. Power of 2. What about the power of 2? Power of 2. Here, I'll show you something that's not second degree that has a power of 2. X to the power of 4 plus x to the power of 2. That has a power of 2, but that's not a second degree polynomial. This is a 4th degree polynomial that I wrote up there. You just need to tweak your definition just by a little bit. Or you can call it someone else that has their hand raised.
A second degree is when the highest exponent power is 2.
There it is. So the biggest one is 2, exactly. The highest term. So I'll say highest I ran out of room here. Highest power is 2. Oh, I already wrote power. So yeah, highest power of 2. Sure, that works. Okay, so the other thing is when the leading coefficient has to be this number. What number do you think we need to have for our leading coefficient? What's the easiest number of them all, Charles? 1. You need to have a leading coefficient of 1. If you do not, then you need to either go back to step 1, factoring out the greatest common factor, which is usually the common mistake, or if you have factored out the greatest common factor, you have to do advanced ninja star, which we're not doing today. All right, so generally speaking, you'll have a second degree trinomial that looks like this. So there's a hidden 1 here, because the leading coefficient is 1. So 1x squared plus bx plus c. In words, what we're trying to do is we're trying to find two numbers that add to b and two numbers that multiply to c. We use the ninja star as a tool to help us remember that. Does anyone remember where b and c go in our ninja star? Gunnar?
Does B go on the top?
B go on the top, and then it actually is the reverse. Usually we put b on the bottom. And do you remember which one is adding and which one is subtracting, though?
C is adding.
Ooh, it's the other way around.
I got it.
Yeah, so C is multiplying and B is adding. But again, as long as you just remember that the last number is the one that you're multiplying to and the middle coefficient is the one that you're trying to add to, you don't need the ninja star. You can just do these in your head. In fact, when Anya came, I don't know if anyone met Anya, our foreign exchange student from a few years back, she told us that the ninja star and everything like this is completely foreign to her. What she does is she uses an equation every single time. The way that she uses her equation looks like this. She says she says A times C is equal to some number, and then, they do P and Q, never mind. So they say P times Q is equal to C, and P plus Q is equal to B. This is what we are really doing, but with the ninja star, because this might be confusing. The ninja star is a nice graphical way of seeing what's going on. We're solving for P and Q. We're solving for one variable and another variable, the left and right sides. All right, so once you find your number over here, we'll just call this number 1 and number 2. Actually, we can solve this, right? So, we can't because I didn't give you guys a problem yet. I'll say number 1 and number 2, make this as general as possible. Once I find out what P and Q are from Anya's equation, once I figure out what the number on the left and the right are, these two numbers have to add up to B, and these two numbers have to multiply to C, then I'm ready to write it in the factored form. The factored form looks like this. It's x plus the first number and x plus the second number. If this number is a negative, then it will be x minus that number. Oh, and I guess we could have looked ahead too, Gunnar, huh? Here's the procedure. The C goes on top, the B goes on the bottom. Two numbers that multiply to the top and add to the bottom, and then write in the correct form. So this is the correct form. It's in factored form. So maybe I should write over here, instead of in the correct form, in the factored form. All right, let's try it. Example number 1. I'll go ahead and do the basic setup for all of us. We have two numbers that add to 5 and two numbers that multiply to 6. What are those two numbers? What plus what is 5 and what times what is 6? If you are ever struggling with these, do the top first. There are only a certain number of factors for each number. 6 only has 4 factors. 1, 2, 3, and 6. That means the answers over here can only be 1, 2, 3, and 6. All right, what two numbers multiply to 6? And then check that those two numbers also add to 5. Andres.
3 plus 2 adds to 5, and it also multiplies to 6.
There it is, 3 and 2. All right, and how do I write this in factored form now? Come on, I want to get someone new. I've been counting on the same people over and over. How do I write this in factored form? Fernando. So look up here. It's going to be, I'll do the basic setup. I'm going to basically rewrite this, but I'm going to leave it blank for you. I'm rewriting x something, x something.
Is it plus 3 and then x plus 2?
There it is. And then we box it. We have now factored it.
You wrote
Ah! Thank you. I guess I could do 3 and then 2, huh? 3, x plus 2. Thank you. Yes, Andres.
Do the numbers have to be in a particular order, like 3 first, or
It does. Yeah, great question. Does it need to be in any particular order? No. I could have written x plus 2 and x plus 3. I could have done 2 then 3. It doesn't matter. Great question. All right, let's try another one. Example number 2. Again, ninja star this. I need a quiet raised hand. Tell me where the numbers go. Where does the 2 go? Does it go on the top or the bottom? Everyone just point. The 2, does it go top or bottom? Point. Everyone's pointing down. The 2 goes on the bottom. It's 2 numbers that add to the 2. And then obviously this one is multiplied to negative 15. All right, start going through the factors of negative 15. 1, 3, 5, 15. Okay, 1, 3, 5, 15. If I add up these numbers, it adds up to 2. If I multiply the numbers, it multiplies to negative 15, which means one of those numbers has to be negative. 2 people have an answer so far. I'm going to give more time. I want you guys to think about this. I have 3, 4 hands, 5 hands, 6 hands. Yeah, Jessica, was your hand up?
Is it negative 5 and 3?
It is really, really close to negative 5 and 3. Here, I'll show you negative 5 and 3 adds up to negative 2. So how would you change your answer?
Negative 3 and 5.
There it is, yeah. So negative 3, and I can do this in color too. Negative 3 and 5, perfect. Who can write this in factored form? Josie. Yep, x plus negative 3, and that's the same thing as x minus 3, right? Okay, and then keep going. Done, thank you. All right, let's try a harder one. Example number 3. Wait, Mr. Sindel, we can't do that. The leading coefficient, it's 2. We're not allowed to have that. You're right. So what should we do? Can't do it. Yeah, just give up, right? No. Okay, what do we do? What's our first step that we're always doing for every single problem? Go back to the very front of your notes. Step number 1, I'm waiting until 100% of our hands are raised. Everyone look at step number 1 right now. What is always the first step in every single factoring problem that you have? Everyone raise your hand. Even if you don't know the answer, I'm waiting until everyone raises their hand. I'm waiting for Josie and Sergio's hand. Josie has to raise her hand. Yeah, Cohen. There it is. That is always, always step 1. And with another quiet raised hand, what is the greatest common factor? Jose. 2, yeah. So I'm going to factor out the greatest common factor, which is 2. Do you want to do the rest of it, Jose, or do you want to give it to someone else? If you don't mind, yeah. Negative 10. $24? What about that first term? X squared. There it is. All right. Jose and Cohen have factored out the greatest common factor. Now, this leading coefficient is 1. Woohoo! Okay, we're going to ignore the 2. The 2 is still in our answer. Don't forget about this 2. In fact, I'm just going to keep writing the 2 over and over so I don't make that mistake. 2, 2, 2. I don't know if I need them all, but don't forget the 2. It is probably the most common mistake when it comes to quizzes and tests. I factored out the greatest common factor, but then I forgot to write it in my final answer. All right, so now I'm going to do the ninja star on this inside of the parentheses. All right, negative 10 goes on the bottom. 24 goes on the top. What two numbers multiply to 24 and add to negative 10? Go through the factors of 24. What times what is 24? Make sure those two numbers also add to negative 10. What two numbers multiply to 24 and also add to negative 10? Jenny. Say that one more time. 6 and... Ooh, really close. 6 times 3 is 18. 6 times 4. Okay, you're like almost there. 6 plus 4 is a positive 10. Negative 6 like that? So negative 6 times positive 4 is a negative 24, and negative 6 plus 4 is a negative 2. You're so close. One more. Yeah, both of them are negative. Exactly. All right, and then I need to write this in factored form. Thank you, Jenny. What do I do next? Sergio, thank you. Sergio, what do I do? Factored form.
X minus 6 parenthesis x minus 4.
There it is. I didn't even need all those 2's. There it is. Final answer. Box it. All right, and then example number 4. All right, now I'm going to have less training wheels. I'm just going to ask you guys what to do each time. What do? I'll let you guys think about this. I'm waiting for a few more hands. I see White has his hand raised. See Sergio has his hand raised. Jade has her hand raised. Charles has his hand raised. Jose has his hand raised. Question? Yeah, what's up, Andres?
When it's a negative, do you have to factor so or not?
That is a great question, and that's such a good question that I'll turn over to the class. All right, repeat your question one more time so everyone can answer it.
When you have a negative, do you still have to factor it out or factor out?
What do you guys think? Thumbs up, thumbs down. Do you have to factor out that negative? Do you not have to worry about it? You do, yeah. Thumbs up. You somehow have to factor out the negative, and that is the first step. So who can help me factor out the negative for the first step? Wyatt.
So when you factor out the negative, you want to put the negative outside the parentheses, and then inside the parentheses we would have x squared minus 5x minus 14.
There it is. Essentially, we're just switching the signs, right? Switching the signs, and now we have a leading coefficient of 1. It looks like there's nothing, right? Now we can do a ninja star. I'll help you guys set it up. The ninja star is a tool that helps us ask what two numbers add to negative 5 and also multiply to negative 14. And this is the most important part of the lesson, figuring out these problems, the ninja star problems. If you don't know where to start, what two numbers first multiply to negative 14? Then once you figure out those two pairs, do they add to negative 5? If not, try again. Find two new factors of negative 14. Charles.
Negative 7 and positive 2.
Negative 7, positive 2. Jade, write this in factored form for us, please.
Minus x squared, no, just x, minus 7, and then x plus 2.
There it is. And final answer, we box it. On to our final example. What do I do first? Andres.
So you're going to have to factor out the negative. So you put the negative in front of the equation.
Okay.
Parentheses. It's going to be 3x squared plus 9x minus 12.
Nice. Each of them switches a sign. All right. Next. Charles.
The 3 should be the negative outside of the parentheses.
Oh, you mean we should factor out the 3 as well?
Yes.
Why?
Because you have to start with the 1x.
Okay, yeah. So let's go ahead and factor that out as well. What is our new problem going to look like?
It will look like -3 quantity of 3x plus -4.
Oh, I think I messed that up. So, what's the first term that goes right here?
X squared, sorry.
X squared.
Plus 3x minus 4.
There it is. It's essentially dividing everything that we had up here, this trinomial. We just divided by 3. 3x divided by 3, 3x squared divided by 3 is x squared. 9x divided by 3, 3x. Negative 12 divided by 3, negative 4. Yeah, Jade.
Would it be x squared plus, or minus 3x? Because the negative and the negative is positive.
Yeah, so we originally had a negative 9x. If we divide that negative 9x by the negative 3, and negative divided by negative is positive.
Oh.
Yeah, it was a little bit confusing. We factored out the negative in one step and then the number in the next. All right, what do I do now? What?
You're gonna want a ninja star.
Ninja Star. All right, Ninja Star is a tool that helps us ask what two numbers multiply to -4 that also add to 3. Jose?
-1 and 4.
-4? Oh, -1 and 4. -1 and 4. Looks good. Thumbs up. We're good. All right. And finally, write this in factored form, and we are done. Last participant of the day. I think I got everyone right. Last participant. Who wants to do it? Last answer. Why? Go for it.
So you're gonna want to keep the -3 out front. Then parentheses x minus 1 times x plus 4.
There it is, and we box it. All right, give me a fist of 5 for the entire lesson. How well can you factor out trinomials that sometimes have a greatest common factor in them using just Ninja Star? I'm seeing 5s and 4s all around, mostly 5s though. All right, that's it, thanks.